Okay, so if you're not done, well, however far you are, let's start talking about these so we don't run out of time because today is a little bit short of a block because it's Wednesday. So number one third to the 0 power. What do my rules for exponents say to do? Yeah, they say two things, right? These are the rules that we took a couple weeks ago. They say two things, right? They say anything to the 0 power is 1. Or there's another rule for this one too, right? It kind of looks like this guy too, right? One third to the 0 power. We distribute the 0. So the 1's going to get a 0 and the 3 is going to get a 0. Still though, what are you going to get as an answer? Positive 1, yeah. Doesn't matter which way you do it. You're going to get positive 1 as an answer. Okay? Number 2, 3, regular 3 to the negative 1 power. We have a rule for that, right? Right? So if it's a parentheses, we distribute, so we get 3 to the negative 1, right? Okay? What do negative exponents tell us to do? You guys did this on the quiz yesterday. You had a few problems where you had negative exponents. What did you do with you had negative exponents? Move them down or move them up, right? Either one or the other, right? If it's up, move it down. If it's down, move it up, right? You guys did that. Same thing. So is 3 up or is 3 on the bottom? It's on the top, right? Because if it doesn't have a bottom, that means you got to make one. So that means you move it there. 3 to the first power is 1/3, right? Okay. The last one. Well, again, if I have a fraction to a power with parentheses, what do I got to do? Distribute the power. Okay. So when I distribute the power, I get 2 to the negative 2 and 3 to the negative 2. And then what do we do with negative exponents? What did we just do with them? What did you guys do yesterday on the quiz? Move them up or move them down, right? Move them up or move them down. And then when you move them, they become positive exponents. Okay. So you get 3 to the 2 power and 2 to the 2 power. 3 to the 2 power is 9. 2 to the 2 power is 4. Leave as a fraction if it's a fraction because you can't reduce that fraction. Okay? So we've done that before. That's not new. These questions are not new. You guys have done those. My thing is there a shortcut? Is there a shortcut to go from here to here? Is there a shortcut? Because we know the way, right? I'm not going to teach you the short. There is a shortcut. I'm not going to teach it to you, but does anyone see it? Is there a shortcut from here to at least here? Right? Anytime I have a negative exponent, what do I have to do first? Flip. And then what do the powers become? Right? So from now on, if you have this, it'll make your life a lot easier, especially today. And then you could probably do this in your head. Once you flip them, you can say, oh, 3 to the second power is 9. 2 to the second power is 4. Right? So instead of doing before the quiz, I wanted you to write them out because it was important. But now since we took the quiz, try to go from there to there. Okay? Try to do this part right here. Try to do it in your head. See if it works. Okay? Because you're gonna get a lot of practice of that today. This is the hardest part about today, doing these things. My second period, I don't know if they forgot it or what, but they were having issues with this. That's why I did this first, because if you can do these types of problems, today is not going to be hard at all. Okay, so let's go back to the notes real quick. Okay, so exponential equations. Exponential equations have 3 parts. Another name for A is called the starting value, where you start, or y-intercept. Okay, The starting value or the y-intercept. So if we need to know the y-intercept, we look at A. B is called the multiplier because that's the thing being multiplied, right? X is the variable, right? How do you know if something's an exponential function? Because the variable is always up top. The variable is always up top. If the variable is up top, it's exponential, and it's going to fit into what we're doing today, okay? We've looked at equations. We've looked at equations, the one on the board here. If you're in class, you can see the x squared plus 2x plus 4, right? That's got an exponent, but this wasn't exponential. Why not? Because the exponent is a number. It's not a variable, right? The variable is down on the ground, right? So if the variable is up in the air, it's exponential. That's how you can tell. You always can tell by if the variable is up in the air, okay? All of the things we look at today, you can look. Where is the variable for all of these guys? Up in the air. Up in the air, right? Same thing with the back page. Same thing when you flip over. Variables up in the air. That's how you know it's exponential. Okay? Easy to tell. So when it's exponential, what does that mean? Well, there's two types of exponential. Growth and decay. How do we know if something is growing or if something's decaying? Decaying is the opposite of growing, right? Dying, right? We look at the graph, right? So growth is going to look like this. It's going to be a curve, and it's going to go up. Decay is going to look like kind of the opposite, kind of a reflection. Okay? Here's my question. How do you know which way is up? Because I've had some people tell me red is going up. I've had some people say blue is going up. I've had some people say red is going down. I've had some people say blue is going down. How do we know if we're going up or down? Yeah, Jose? You look at the Y, right? How do we read a book? If you're reading a book, we start on the left side and we move to the right. And then when we're done, we move back, right? In the English language, that's how we read. That's also how we look at a graph. So what I want you to do right now is with the tip of your pencil on the red, on my red. I know it's not red on yours, but on my red. Where is the start of the graph going to be? Where is the start of the graph going to be? Yep, your pencil should be right here on this arrow here. Your pencil should be right here on this arrow here. And then as I move to the rest of the red, is my pencil going to go up or down? It's going up, right? That's why it's growing. The blue, where does that one start? That one starts on the top, right? It starts on the top. And then as I move my pencil to the right, where does it go? It keeps going down. That's how you can tell. Start on the left, move to the right. Okay? That's how you tell with a graph. Now, what if they don't give you a graph? This is how you tell. You're going to look at B. If B is bigger than 1, it's always going to be growth. It's growing. It's going to look like the red one. If B is smaller than 1, it's going to be going down. It's going to be dying. So anything smaller than 1, fraction, decimal, negatives, it's going to be going down. Okay? What if B is 1? It's just a constant straight line. Yeah, no curve at all. Doesn't grow at all, doesn't die at all, just stays. Right? Okay? So one other thing with these guys are going to have what's called a hard bottom. The hard bottom or the hard floor, sometimes it's hard floor, is called an horizontal asymptote. Horizontal asymptotes are like hard floors. The red can't go through. So for this guy, it would kind of be right here. For this guy, it would kind of be in the same spot, right? So how do we label those? Well, which one is it passing through? Is the orange passing through the y or the x? It's passing through the y, right? So we always say y equals and then a number, wherever that is. Y equals and then whatever number it's passing through. That's how we label it. Okay? Now, is it going to have a top? Is it going to have a hard top? Is the red or the blue going to have a hard top? No, because it's always going to bust right through it, right? Like I can't put a top there because it's going to go right through. What if I put a top right here? Does that work? Still going to bust through, right? I just stopped it, but the arrow means it keeps going forever and ever and ever, right? Same with the blue. Okay? So it always has a hard floor, but never a hard top. Okay? Okay, so bottom. Each of these guys, we have to classify without looking at a graph, because I don't have a graph. Is it growth or decay? So let's look at number one. Let's look at number one. What do we look at? We're looking at B. B is the guy. How do you tell A versus B? B is the guy with the exponent. Yeah, B is the guy with the exponent variable. So who has the exponent variable? 2. Is 2 bigger than 1? Yes, it is. So that means this guy is growth. Okay. Number 2, I got 2 fractions and a -1. Which one for number 2 is the guy I'm looking at? 1/4, 3/4, or -1? The guy with the variable, right there. It's the only guy I care about. So is 3/4, is that bigger than 1 or smaller than 1? Smaller than 1, yeah. 75.75, 75 cents. 75 cents is less than $1. Number 3, 3/2. Yeah, sometimes you see a fraction and you're like, oh, decay, it's a fraction. But when I put it in my calculator, it's going to be 1.5. That's bigger than 1, yeah. So you got to be careful. If the top number is bigger than the bottom, it's going to be over 1. It's going to be a growth. Okay. Number 4, what is B? B is 1/4, so that one's going to be decay. Yep. Good. Number 5, what is the growth? Or what is is it growth or decay? Yep. 5/6. 5/6 is the guy that I'm looking at. That's B. That's barely below 1, so it's decay. And then the last one, I don't have any parentheses. But which one? 5 or -8? Yep. Growth. So if I was to graph each of those, I would expect the growth to look like the red one, and I would expect the decays to look like the blue one. Okay? That's the picture that's in your head. All right. Let's look at number 7 now. Now what they want us to do is they want us to go through all parts of it. Okay? So I have to do some of these now. Okay? So I have some x values, right? I have 5 x values. Where do I plug in each of those? Right here in the x, right? The only spot to plug it in, the x. So instead of x, I'm going to write for the first one, -2. The second one, -1. The second one, 0. Oops, not there, 0. The third one, 1. And the last one, 2. So today your calculator is going to be really handy today. Okay, if you have a phone, use it as a calculator, because the calculator is going to be really handy today because it's going to help us with these. Some of these are easier than others. Okay. 2 to the -2. Don't say -4. It's not -4. We just did one like that. 2 to the -2. 1/2. It's going to be 1/2 to the second power, right? Move it to the bottom. 1/2 to the second power is 1/4, which is the same as 0.25. quarter. You see the negatives, and sometimes you want to throw a negative in there. No, that's not how it works. Go back to what we did on the quiz, right? Negatives move down or up. 2 to the negative 1. So that one's going to be 1/2, yeah. That one's going to be 1 over 2 to the first, which is 1/2, which is the same as 0.5. 2 to the 0. 1. That one's the easy one. Anytime you have anything to the 0 power, it's easy. Just 1. 2 to the first. 2 to the second. Done. Okay. So I have 5 dots. I'm going to highlight them in green. I need to go make those dots on the graph below. Okay. So the first dot is -2. Go left 2, up 0.5. So I go left 2, and I barely go up anything. I don't even go up a full unit. 0.25 is not even a full unit. The next one, -1, 0.5. So go left 1, up 1/2 a unit. It's a little bit higher, but you can barely even tell. I went up, but you can barely even tell because it's not even a full unit. Okay. The next one, 0, 1. Up 1. Now I'm at +1. The next one, 1, 2. And the last one is 2, 4. Okay. It's growth, right? It looks like the red one. It looks like the red one from the front. So I'll draw it in red. So now you're just going to connect the dots, sketch it as best you can. It's a curve, so it's not really a straight line. It's not a straight line at all, but kind of do the best you can. First question was, is it growth or decay? Growth. Yep. We see from the picture, and A is positive, or B is positive, 2. So we know it's going to be growth. Asymptote, where's that hard floor? Y equals what? There you go, right? It's not going to be down here, because that would be y equals -9, right? It's going to be up. So how far up do I go? Right there, 0, right? So it's going to be y equals 0. Y equals 0 is the hard floor. Y-intercept, where does it cross the y-axis? At 0, 1. Remember, y-intercept always going to have 0 for x. That's why it's a y-intercept. Okay, domain. Domain. We've talked about domain, but we haven't talked about it in a while. Okay, domain are the sides, edge to edge, left to right. Okay, so if I wanted to, this red guy, if I wanted to put boundaries on it, left to right, where would they be? That's pretty much what it says. So for example, if I wanted to, let me pick a different color. Okay. Nope. So let's say I wanted to put a line here, a boundary there. Would it eventually go through that pink? Yes. So where would I move the pink? I could shift it this way, right to the left. How far would I have to shift it so that eventually the red wouldn't go through it? Exactly. I could all the way as far as I can go, right? So which way is this? This is the negatives, right? The left is negatives. So it would be negative infinity. Negative infinity. Okay? So that's the start of it. So we say negative infinity. Now let's do on the other side. So let me draw another line. Say one right there. So if that red dot, if that red arrow up here kept going, would it eventually cross over that pink line? It would. It would eventually. Somewhere way up here, right? Somewhere way up here, they would eventually meet. Because this guy is not only going up, but it's kind of going to the right. It's going up and to the right. So eventually it would cross, right? So how far do I have to move that pink line this way so that it won't ever cross? Infinity again. So I'm over here on the right. So it's getting bigger, right? So it's positive infinity. Mm-hmm. That was my next point. Yeah, that's a good point. My next point is, I'll give you a hint. All of the graphs we see today are going to have the same domain. The domain will be the same. Negative infinity to positive infinity. Yep. Because they're all going to look like this. They're all either going to look like the red or the blue. Right? So the same rules apply. So the domain's always going to be the same for these guys. For exponentials, it's always going to be negative infinity to positive infinity. So the domain. The range is different. We're going to do the range next. The range is the hard floor to the hard top, right? We have a hard floor. It's called the ground. We also have a hard top. It's called the roof, the ceiling, right? Does this guy have a roof or a ceiling? Well, didn't we already write one? Which one did we write? The floor, right? We already know where the floor is, so let's start at the floor. Where is the floor? 0. So that's where it's going to be. It's going to go from 0. Where's the hard top going to be? It's going to go up and up forever and ever and ever and ever and ever. So it's going to be positive infinity, right? This is the floor. This is the ceiling. Floor, ceiling. It goes floor to ceiling. Where's the floor to where's the ceiling? Okay. All right. That's what we're going to do for the next one too. The next one though is a fraction. 1/3. Okay, so let's plug in x. Yep. Okay. So I got to plug it in for x. So now, is this going to be growth or decay? Before you even graph anything, is it going to be growth or decay? Decay. It's going to be decay, right? Because 1/3 is 0.33. That's less than 1. Okay. So here, yeah, 1/3 to the negative 2 power. Distribute. The bottom moves up. The top moves down. 9, 3 squared is 9. 1 squared is 1. There you go. Right? So 3 and 1 switch spots, and you'd make it positive. So it's really what I did was just the 3 and the 1 switch spots, and then the 2 became positive. That's all you ended up doing. That's the shortcut. Okay, so what is the second one going to be? Positive 3. Next one's going to be positive 3. The next one, I could distribute the 0, but anything to the 0 power is what? 1. So you could distribute it, but you would just get 1/1, which is still 1. Anything to the first power is what? Itself. Yeah, 1 to the first over 3 to the first, which is just itself. Which is the same thing as 0.33. Usually I change it to a decimal when I have to graph it, and I'm going to graph it later because it's easier to graph decimals than it is fractions for me anyways. The last one, distribute the 2. So I get 1 over 9, which when you put it in your calculator, you get 0.1111 forever and ever and ever, so 0.11. Okay, go make 5 dots. Left 2 up 9. Left 1 up 3. Up 1. Right 1 up 0.33. And then the last one, you're barely going up anything. 0.11 is you're not even going up 1 full. Not even half a unit. Okay. Okay. There's the graph. Fill out the rest. Do the 5 boxes down there. Do the 5 boxes. I'll give you a hint. I'll give you one of them. One of them, domain is going to be the same. Give you about a minute to fill out the rest. Growth or decay, asymptote, where's the hard bottom? Where does it cross the x-axis, y-axis, and what is the range? Okay. Decay, the hard floor is on y equals 0, same as the one right before it. Crosses the y-intercept, same spot, 0, 1. Domain, always the same. And range is the same because the floor is at the same and it goes up forever and ever and ever. Okay. All right, let's look at the next guy now. Let's look at the last 3 problems here. Okay, this is where your calculator is going to be your best friend because your calculator will do this work for you. You just have to tell it the right things to do, right? Our calculator doesn't think on its own, right? We have to tell it what to do. So we have to make sense of it, okay? So where are we plugging in these numbers, for x or for y? X, always x, right? So we have 3 to the negative 2 minus 2. 3 to the negative 1 minus 2. 3 to the 0 minus 2. 3 to the first minus 2. And 3 squared minus 2. I want you to do those right now on your own. I'll give you a hint. A few of them will be negative answers. It's okay. A few of them will be negative answers. It's okay to get a negative answer. You should know what it's going to look like because we know that this one is, which one is this, growth or decay? Growth. So we know what the picture is going to look like. That's the way to tell. If your dots line up like a growth, you did it right. Okay, I'll give you about 3 minutes to do number 9, and then we'll do it together. Okay? So 3 to the negative 2 is 1 over 3 squared, which is 1 over 9, which if I put in my calculator is going to be the same as 0.11. So I have, so this guy here is 0.11. So in my calculator, I'm going to say 0.11 minus 2, subtract 2, right? And that's going to give me a negative. Leave it go 2 spaces. So negative 1.89. Almost 0.9. That's the first dot. So that one I go left and then down. The next one, 3 to the negative 1. 3 to the negative 1 is 1 over 3 to the first power, which is 1/3. 1/3 is 0.33. If I divide my calculator, 1 divided by 3, it's 0.33. So I have, no, I don't want to play games. I guess I won't use that calculator. Okay. So we got 0.33 minus 2. You get another negative. Negative 1.67. Okay. The next one is 0. 3 to the 0 power. Anything to the 0 power is just 1. So this guy right here is just a 1. So 1 minus 2 is negative 1. So I have another negative. It's okay. The next one, 3 to the first. 3 to the first is just 3. Minus 1, positive 1. The last one, 2 squared. What is 2 squared? 9, right? 9 minus 2 is 7. Okay, there are my dots. Go make 5 dots. So the first one, negative 2. So I'm going to go left 2 and then down almost 2. So I go left 2 and then down almost 2. The next one is negative 1. I go left 1 and then down a little bit less. And then 0, negative 1. And then 1, 1. And the last one's 2, 7. Growth. We knew it was going to be growth. Okay. All right. So we know it's going to be growth because 3 was B. All right. Where's the hard bottom? Negative 2. Yep. Y equals negative 2. I'll give you a hint here. Look at the original equation. Do you see a negative 2 anywhere in there? That's a hint right there. That'll tell you where the hard bottom is. Negative 2. Look at the last 2 we just did. Did that one have a minus anything or a plus anything out here? So really it was just this, right? Plus 0. And where was the hard bottom? Okay. That's how to tell where it is. That's a quick way of telling where it is. Okay. Y-intercept. Where does it cross the Y? 0, negative 1. Domain is going to be the same since it looks the same as the pictures, since It's the same growth one. Range, we start with the hard floor. Where was the hard floor? There you go. Okay. We'll finish the last two tomorrow. Okay, so don't lose these. We'll finish the last two tomorrow. Okay, we'll tape and do the last two tomorrow.